It's time for another amazing chemistry video with Mr. Stapleton, proudly sponsored by Farmers Union Nice Coffee.
Hi guys, this video is just going to be doing some naming of alkanes, alkenes and alkynes. So these are kind of the basic organic chemistry molecules. I've just got 5 examples here. These 2 over here I'm going to be going through and drawing for you. We're going to be starting over here with naming these 3 molecules that we've got. Okay, I'm obviously not going to be able to go into a lot of depth. I want to keep these short and sharp for you, but hopefully just give you some examples that you can go ahead and use while you are trying to learn how to do these. If you haven't watched the video with just the basic rules, you need to go back and have a look at that one. That's the intro to organic chemistry, because I'll be referring to these. So what I'm going to start with is these 3 molecules here. Okay. When you've got alkenes, alkenes only have a carbon-to-carbon single bond in there. Okay, so if you've got no double or triple bonds, it's an alkane and your name ends in A-N-E. If you put a double bond in there, it's an alkene and your name ends in E-N-E. And similarly, if you've got an alkyne, that's a carbon-carbon triple bond, and you have a Y in there. Basically, these all tend to burn, all right? But as you increase the number of double or triple bonds you have, you increase what we call the degree of unsaturation. So you don't have as much hydrogen as possible. And alkenes and alkynes are characterised by when they burn with quite a sooty flame, so a very black flame, and they tend not to release as much energy as alkanes. Okay. A double bond and a triple bond are a functional group though. They're a reactive site in a molecule, so we can react and add things across them, which makes them very useful to have in organic molecules. So first thing I'm going to start with is just this simple molecule over here. I'm not going to go through drawing and naming alkanes because it's just increasing the carbon chain length as you go. Okay, but for this one up here, we've got 2 carbon atoms. Okay, so that makes it eth, ETH. All right, we've identified that it's an alkene because there's a double bond in there. So this is ethene. Okay, so that's just how we name a double one. That one's a very simple molecule to start with. This one here, we now start to go a little bit more in depth to. Okay, so we follow through our steps, we identify the longest carbon chain, and I've drawn it nicely obviously, but it's straight across, so we've got 6 carbons in there. Okay, we've got a triple bond in there, we've got an alkyne functional group in there, and we've got these 2 side chains, we've got 2 methyl groups on there. Okay, so what we do is we start numbering the carbon atoms. Now in this one, this is a really good example of where we can number from either end, because the functional group's right in the middle. Okay, so we could go 1, 2, 3, 4, 5, 6, or we could go 1, 2, 3, 4, 5, 6. In this case, it's not going to change where the triple bond is. However, these 2 side chains are closest to this end. So we're actually going to start numbering from down here. So that's our first, second, third, fourth, fifth, and 6th carbon that way. So then we go through and name our molecule. Okay, what we've got is 6 carbon atoms. On the 3rd carbon, we have an alkyne. Okay, so 6 carbon atoms makes it hex. Okay, and on the 3rd carbon, we start our triple bond, so it's hex 3-ine. Okay, now on the 2nd carbon, we have 2 methyl groups. Now the prefix we use when we've got 2 of something is di. So we go 2, 2, all right, because there's 2 of them. They're both on the 2nd carbon, because it could be 2, 5. It could be 2. It couldn't be 2, 6. It could be 2, 5 is the other option we could have. Okay, so it's actually 2, 2 dimethyl. Okay, sorry, my yellow pen's running out. Okay, so it's 2, 2 dimethyl hex 3-ine. So this indicates for us that we've got an alkene, a triple bond functional group. That's in a 6 carbon chain. The triple bond starts at the 3rd one, which we've got up here. This indicates we've got 2 methyl groups here. All right, 2 methyl groups, and they're on the 2nd carbon atom, both of them. 2, 2 dimethyl hex 3-ine is the name of this alkyne. Final one we've got down the bottom here. Oops, and hopefully you've been able to see by now that I've actually missed out a hydrogen, because remember every carbon must have 4 bonds on it, so there is a hydrogen there. Okay. So in this one, again, you follow through the longest carbon chain. So it's actually 4 across there. It could be 4 that way as well, but because we've got a bromine on this one, we're going to go with this 4 instead of this 4. Okay, so we're going to go across this way. We're going to number them from the end closest to, in this case, the bromine, because we've got a methyl group on either of these 2 carbon atoms, so it doesn't matter which end we number for those. Okay, however, we do have the bromine over here, so that's our 1st, 2nd, 3rd, 4th carbon atom. Okay, so we start from this one, the bromine on here. Now the bromine doesn't going to affect the ending of our name because it's an alkane. So it's going to be 4 of them, so that makes it butane. Okay, so we're going to have butane is the name there. But then we've got our other functional groups here. We've got methyl, and we've got bromo. So which one do we start naming first? Because all 3 of these are side chains. Well, what we do is we start using alphabetical. So B becomes before R, so bromo before methyl. So we name that first. Okay, so it's going to be 1 bromo. Okay, and then on the 2nd and the 3rd carbon atom, 2, 3 dimethyl butane, and I will swap over my pens before the next video, sorry guys. Okay, so it's 1 bromo, 2, 3 dimethyl butane is our 4 carbon atoms long for our chain. So that's an example of an alkene, an alkyne, and an alkane, and how we name them following through those steps. Now what we're going to do is we're going to come over here and we're going to actually draw our different structures over here. So I've got 2-chloropropene over here. Okay, so propene, ENE, indicates it's an alkene. So when you're drawing them, I always suggest you start by drawing your skeleton structure first. So pro means 3, so we've got 3 carbon atoms. 1, 2, 3, like that. So you just draw them in, and that's your starting point. Alkene, ENE, implies that we have a double bond in there. So we're going to put our double bond in. Then you go to your naming at the front, 2-chloro. Okay, so on the 2nd carbon there, we're going to have a chlorine. Okay, and that is our skeleton of 2-chloropropene. All we've got to do now is put in our hydrogen atoms. We know how many to put in because remember every carbon has 4 bonds around it. So this carbon in the middle already has 1, 2, 3, 4, so that doesn't need any more. This carbon here needs 1, 2, 3. That gives us our 4 bonds around this carbon, and this carbon down here already has 2, so we just need to put in 2 more. Now if you did them up and down, it's probably not too much of an issue, but because it's a double bond in there, we get a trigonal planar arrangement around that carbon. So if you can show that you understand those different trigonal planar tetrahedral arrangements depending upon the bond configurations, you're doing pretty well. But for the moment, if you just want to have them hydrogen-hydrogen, they wouldn't penalise you for that. So that's 2-chloropropane. That's how you go through and just identify your skeleton structure. Here, hept 1 ion. So hept means 7. So again, what we're going to do is go through and put our 7 carbon atoms in. Okay, so there's our 7 carbon atoms. We then look at the function group, YNE. Alright, YNE makes it an alkyne, so it's a triple bond. So this first carbon here is going to have a triple bond on it. Okay. Then we have a look at the side chains we've got. We've got 3,3-diethyl. So ethyl means we're going to have 2 carbons in the side chain. So on the 3rd carbon here, we're going to have a carbon and a carbon. And on this one, we're going to have a carbon and a carbon. Okay. So that is the skeleton structure for 3,3-diethyl. So 2 carbons there, 2 carbons there. We've got 2 of the ethyl groups. They're on the 3rd carbon, both of them. Hept makes 7 carbon atoms long. 1 shows us where the triple bond is because it's a YNE. Then you go through again and finish up all your carbon atoms having the correct number of bonds in there. Right? So for the side chains, otherwise it's going to get messy, I'm just going to start putting a condensed structure in. So CH2, CH3, like that. Okay? That allows us to have the 4 bonds around them. We could do the rest of the bonds on here as well. What I encourage you to do is to not get lazy, alright? When you just don't put the carbon atoms in, don't put the hydrogen atoms in, you start to get into the habit of doing that, okay? And the problem with that is you end up doing that in the exam as well. So I always encourage you to finish it off. Here we go to this final one. This carbon has 1, 2, 3, 4 bonds around it. This carbon has 1, 2, 3. It needs 1 more hydrogen there to finish off. And over here we've got 3,3-diethyl hept 1 ion. And that's how we draw. I think I always find it easier to draw based on the name rather than necessarily going from the naming, but I suggest you practice both. Hopefully this has been fairly straightforward for you. Next one I'm going to do, we'll be looking at alcohols, and we'll start looking at how you bring in some of these other functional groups and adding the names in. Thanks guys.